Welcome back. I titled this section Volcanoes in Arizona? Because most people I talk to are like, what? There's volcanoes in Arizona? Yeah. Yeah, there are. In fact, there's a lot. So what you see here is a distribution of volcanic rocks, therefore volcanic activity, throughout Arizona, going back 0 to 200 million years before present. So 200 million years ago, from 160 to 200 million years ago, volcanic activity kind of isolated to the south. 50 to 82 million years ago, kind of coming up a little bit more north. 11 to 38 million years ago, kind of through the Basin and Range Province. 5 to 16 million years ago through the transition zone, and 4 million years ago to present, pretty much in the Flagstaff, Springerville area up kind of more north. So there's a lot of volcanic areas around Arizona. Yeah, a ton. So some examples. SP Crater, a very famous cinder cone volcano just north of Flagstaff. This is on private ranch land, but you can still get here. In fact, you can park on this backside here, and I think you can take this dirt road to this dirt road to this other dirt road to this dirt road over here. You can park here, kind of climb up this little hill, and then start to climb up this cinder cone. Remember, it's made of cinders, this lapilli, loose material. So it's kind of hard to climb up. It's like climbing up sand, but sand that's sharp and jagged and will cut you. Fun. And it's hard to climb up. I've been up here one time. It's hard. I'd go again. But this is a very famous cinder cone volcano, very picturesque. It's in a lot of textbooks when they're talking about this type of volcanoes. But yeah, you see the associated lava flow as this cinder cone was dying. So here's Flagstaff. Here's the San Francisco Peaks, which is a composite volcano. SP Crater is SP Crater is just north of it. You take 89, get off the highway, head through some ranch land. But everything that you see here, these are all little small cinder cone volcanoes. All these little round figures that you see, these are all little cinder cone volcanoes. So yeah, there's SP Crater. Another famous one, besides all these hundreds of them, is this one over here, Sunset Crater. It's actually part of Sunset Crater National Monument. It's a nice little national monument park. There's nice roads and nice hiking paths, and you can't climb any of the volcanoes here, but it's more user-friendly. SP Crater, you don't have to have an off-road vehicle to get there, but it's kind of in the middle of nowhere, and you got to hike a lot. So Sunset Crater, 20 miles northeast of Flagstaff, again about 1,000-foot tall cinder cone, erupted sometime around 1085, so right around 1,000 years ago. It's the most recent volcanic eruption in Arizona. It formed when kind of a mixture of runny basalt, low viscosity, is mixed with water beneath the ground, and you kind of get a quick explosion. As that rock water soup reached the surface, again, the water flashed into steam, causing the liquid rock to kind of explode from the ground. Kind of this high gaseous water vapor content causing these little pieces to jet out, forming these little cinders, building up this cinder cone volcano. When it erupted, it created a fountain of fire, 850 feet tall. It's pretty big. And then as it died, again, the resulting magma flow. So this is Sunset Crater. Again, this is a nice park you can go to. You can park. There's little hiking trails around the flow area, but you can't hike up Sunset Crater itself. So again, as these tiny little bits of lava cooled off, they fell back to Earth as tiny little cinders, classified as lapilli. These cinders piled up around the vent, creating that cone-shaped pile that you see. There was also larger chunks, blocks, and bombs that got ejected in this area as well. Even lava kind of flowed out and formed a couple of lava flows in the area, the Bonito flow and the Canal lava flow. They extend 7 miles from the base of the crater, or the volcanic cinder cone crater itself. Here's the lava flow. Just a weird noise. I don't know if you can hear that. San Francisco Peaks in Flagstaff. This is the main big mountain in Flagstaff. It is a composite volcano. You can see that this used to be one mountain, and we can use the flanks, the sides of the mountain, to kind of estimate where the peak of this mountain once was. You know, this whole area is what was kind of erupted out, so we can kind of recreate that, basically tracing the flanks, again, the sides of the volcano up. So the San Francisco peaks are the eroded remains of a single, again, much higher composite volcano. And this is just north of Flagstaff. It's the big mountain in Flagstaff. So this composite volcano, alternate layers of kind of ash and pyroclastic flow and kind of andesitic lava, very slow, sticky stuff, constructed by multiple eruptions between 400 and 900,000 years ago. Sometime between the end of the last eruption, about 400,000 years ago, and about 92,000 years ago, the top and northeast flank of the mountain collapsed in a gigantic kind of avalanche landslide that spilled outward towards the northeast. This created a deeply eroded valley where only the topmost portion of the mountain once stood. This is a very bad image now that I'm seeing it, but this kind of collapsed landslide folded out, and flowed out this way. The current high point of the San Francisco peaks is 12,633 feet that form Humphreys Peak. It's called the San Francisco Peaks because once it collapsed, it formed a bunch of different high points along the kind of rim of that. Humphreys Peak is just the tallest one. The calculated high point prior to eruption and collapse was 14,633 feet, so it's 2,000 feet higher than it once was, or it's 2,000 feet lower than what it once was. There's a great deal of weathering and erosion that's taken place the past 92,000 years in the inner basin since that collapse, and in fact during the last ice ages the inner basin would have occupied a glacier that helped to kind of carve it out as well. More on glaciers on a much later unit in the semester. Today we can actually find different glacial rock deposits called moraines left behind by the glaciers and are still readily visible in the inner basin. So this is looking back up the inner basin. So this is the inner bowl that erupted and collapsed and kind of landslid down this direction. This is an area called Lockett Meadow that, if you can get here, is gorgeous. And you can park here. You can do a few camping spots, and you can hike up the interior basin this way. Very, very nice in the fall. But both the San Francisco Peaks and SP Crater and Sunset Crater and all those other hundreds of cinder cones make up the San Francisco Volcanic Field, so named after the San Francisco Peaks or San Francisco Mountain. But all of these are part of this volcanic field. And again, there are hundreds of small little volcanic features, mostly cinder cones here. You can see there's actually over 600 volcanic features, over 600 volcanoes up there. Oh my. All of this formed from a geologic hotspot underneath the northern Arizona area that kind of fed into and melted to that material, feeding that hot magma upwards, creating all of these volcanoes. All of these volcanoes. If there is any future volcanic activity, which there very well may be, the potential site of all of that is most likely off to the west here, kind of where Sunset Crater is, and kind of over in this area somewhere. That's where it would be projected if any volcano in Flagstaff area were to erupt in this volcanic field. So we're going to pause here. So we talked about cinder cone volcanoes, and we talked about composite volcanoes. These are just some highlights. By no means are these the only ones of these in Arizona, just highlighting different types of volcanoes to show you how rich of a volcanic geologic history we have here. So we'll pause here, and I think we have one more video. We'll finish up this section on Arizona volcanoes, and that should finish up this unit. See you back here in just a second.